Good morning, dear students. My name is Ferhan Mazher, and today is 3rd of April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O Levels Physics. The code of the subject is 5054, and today we have set our hearts to solve a theory paper. This is called paper 2, and today we have selected May-June 2013 2-2 paper. This paper 2 belongs from the zone 2, or you can say variant 2. In this video, we will solve the section A of this paper. The section B of this paper I will solve in another video in another session, and soon that will be also uploaded. So let's start today's paper, and hope you will enjoy this video. So May-June 2013 2-2 paper. The time allowed for this paper is 1 hour 45 minutes, and we are going to attempt the section A of this paper. So the question number 1 is showing up on your screen. He says a ball rolls down a slope as shown in the figure 1.1. The meter rule shows the position of the ball at the time t equals to 0, 1 second, 2 second, and 3 second. So you can see the ball at when the time was 0, it was at 10 centimeter mark. When the ball was at the time of 1 second, the ball was at 20 centimeter mark. And the time was 2 seconds, the ball was at 50 centimeter mark. And when the time was 3 seconds, the ball was at 100 centimeter mark. So you can see that during this 1 second time lapse, the ball has covered 10 centimeter. During this 1 second time lapse or time period, the ball has covered 30 centimeter. And during this time lapse of 1 second, the ball has covered 50 centimeter. So you see the distance being covered by the ball in 1 second is gradually during the 1 second or in the time interval of 1 second, it's increasing. So explain how the figure 1.1 shows that the ball is accelerating. So that is the first question which we were talking about. The distance traveled in every 1 second is gradually increasing. That means that the speed is increasing, and that means the ball is accelerating. So let me show you my answer. In the time duration of 1 second, the distance traveled is increasing. I wrote here the word is increasing. So, okay. Then the next part, he says, calculate the average speed of the ball between t 1 second and 3 seconds. So the average speed is the total distance traveled during that time interval divided by the total time taken. So let me show you. So the distance traveled is 100 minus 20, that will be 80, and the time interval is from 1 to 3, that will be 2 seconds. And so you will have the speed is 40 centimeter per second. 40 centimeter per second. So let's have a look. So travel further in each second in same time between images as d by t in the form, and the 40 centimeter per second is the answer. Okay, so our answers are right. Then two of the forces that act on the ball are air resistance and weight. State what, if anything, happens to these forces as the ball accelerates. So the air resistance, that depends upon many factors, but one of the main factors on which the air resistance depends is the speed of the body. The greater the speed of the body, the greater will be the air resistance experienced by that body. So because the body is accelerating, that means the speed of the body is increasing. That means that the air resistance is gradually increasing. Now, the weight during this roll down, it's not changing. So let me show you my answer. So as the speed increases, the air resistance increases and the weight remains constant. And the D part is explained why if the slope is long enough, the ball eventually reaches a constant speed. If that slope is long enough, then eventually what will happen? The speed will be so much because the gradually the speed is increasing, so the speed will be so much that the air resistance will uh, increase, and the resultant force will become zero. Okay, so then the ball will start moving with the constant speed. So let's have a look at the marking scheme. Air resistance increases, weight constant, forces balance, cancel, or no resultant force or resultant of any two forces equal and opposite to the third force. So we are done with the question number 1. Question number 2 says, explain what is meant by the moment of a force. The moment of force, a very famous and frequently asked 2 marks question. The moment of the force means that the body, the product of the force and the perpendicular distance between the line of action of the force and the pivot. So remember this definition word to word. Let me show you. So the product of force and perpendicular distance between the line of action of the force and the pivot is called the moment. Okay. So that's force multiplied by distance, perpendicular distance. Okay, so our answer is right. Then here we have, okay. Figure 2.1 shows a system of raising a heavy piece of metal into a vertical position. A man pulls on the rope with the horizontal force T. The piece of metal has a weight of 2000 Newton and is freely pivoted at A. The system is in equilibrium. By taking moments about A, calculate the T. So this is the pivot. So this weight is trying to produce a clockwise moment. This force here in the rope is trying to produce anti-clockwise moment. The line of action of the weight is this. So its perpendicular distance from the pivot is 2 meters. The line of action of this force is here. So its perpendicular distance from the pivot is 8 meters. So because the thing is in equilibrium, so the clockwise moment and the anti-clockwise moment, they are equal to each other. So we will write 2000 Newton multiply 2 meter is equals to T multiply 8. So let me show you my answer. So the anti-clockwise moment is equals to the clockwise moment. F multiplied D1 equals to T multiplied D2. 2000 Newton multiplied 2 meter equals to tension multiply 8 Newton. So when I will make T the subject of the formula, so 2000 multiplied 2 divided by 8. And when you will enter these values in your calculator, you will get 500 Newton. So the answer is 500 Newton. So let's check. Let's check the marking scheme. Yeah, 500 Newton is the answer. Okay, so the next question is, the force T and the force that the rope exerts on the man are related by Newton's third law. State the relationship between these forces. These forces will be equal in magnitude, opposite in direction, and they will act on different bodies. So that is the relationship between the Newton's pair of forces. Force T and the force that the rope exerts on the man are equal in magnitude, opposite in direction, and they act on different bodies. This word is they. This word is they. Okay. So they act on the different bodies. Two forces equal in magnitude, two forces opposite in direction. So our answer is right. So let's go to the next question. The next question is question number 3. Figure 3.1 shows a man using a chest expander to increase the strength of his arms. The chest expander may be considered to be a single spring. Figure 3.2 shows the force needed to produce different extensions of the spring. So when you apply 0 Newton, the extension is 0 centimeter. When you apply 60 Newton, the extension is 10 centimeter, sorry. And when you apply 120 Newton, the extension is 20 centimeter. When you apply 180 Newton force, the extension is 30 centimeter. The man increases the force on the spring from 0 to 180 Newton. The spring extends by 30 centimeter, and the average force exerted during this process is 90 Newton. Calculate the work done on the spring. You see, the work done is force multiply distance. Force multiply distance. Okay. So let me show you. I have calculated it. So the work done is equals to force multiply the distance, and we have applied the 90 Newton force, and distance moved is 0.3. So the work done will be 27 joules. 27 joules. So let's check. So the answer is 27 joules. So our answer is right. Okay, then they say 20 extensions are made in 1 minute. Calculate the power used to extend the spring. So we have made 20 extension. In one extension, the work done is 27 joules. So they made 20 extensions. So it will be 27 joules multiplied 20. So that is the work done. And this is done in 1 minute. So if this is done in 1 minute, you can find the power. The power is work done divided by time, but the time should be in seconds. So 1 minute means 60 seconds. So work done divided by time, and that 20 multiplied 27, because there are 20 extensions. In one extension, 27 joules of work is done. So 20 multiplied 27 divided by 60, because the time is 1 minute, which means 60 seconds, you get 9 watt. 9 watt is the answer. So let's have a look at the marking scheme. 9 watt is the right answer, sir. Question number 3, B part. Then they say the force at the limit of proportionality of the spring is 800 Newton. Calculate the extension of the spring when the force is 800 Newton. The force at the limit of proportionality of the spring is 800 Newton. Calculate the extension of the spring when the force is 800 Newton. So I will use the proportion method. This much load, this much extension, this much load, how much extension. So let me show you. So when 180 Newton load is applied, the extension is 30 centimeter. When I will apply 800 Newton load, how much will be the extension? So it will be 180 divided by 800 equals to 30 divided by x, and x will be equals to 30 multiply 800 divided by 180, and that will be 133.3 centimeter. So when you will apply a load of 800 Newton, the extension produced will be 133.3 centimeter. Okay, so 130 centimeter, yeah. Then their question is, the force on the spring is increased from 800 Newton to 860 Newton. So just what happens to the extension? Okay, so because 800 Newton is the limit of proportionality, when you will apply a load of 860 Newton, you will cross the limit of proportionality. So try to understand this. First look at this as rough work. So I have used that proportion method, and I'm trying to find out what will be the extension if the load is 860 Newton and the limit is not crossed. Limit of proportionality is not crossed. So x, that will be 30 multiplied 860 divided by 180. So 143.3. So if the limit of proportionality is not crossed and you have applied the 860 Newton load, then the extension will be 143.3 centimeter. But we know that the limit of proportionality was 800 Newton and we have crossed it. So now, because the limit of proportionality has been crossed, so the extension produced will be not 143.3, but more than this. So at the load 860 Newton, extension in the spring will be more than 143.3 centimeter. Why I did this rough work? To show you that from where I am getting this number 143.3 centimeter. So the extension produced when you apply 860 Newton load will be much more than 143.3 centimeter extension. So extension more than 143 centimeter or extra extension is greater than 10 centimeter or more extension and permanent extension. Okay. So that was our answer. So we are moving to the next question. The list below contains three components of the electromagnetic spectrum: infrared, gamma rays, visible light. Arrange the components in order of the increasing wavelength. Okay, so we have to write them in the increasing wavelength. You know, the code word is Ronald McDonald is very ugly except Gary. From left to right, when you move from left to right, the wavelength decreases. But if you move from right to left, then the wavelength will, increase. So the gamma rays come the first; they have the shortest wavelength. Then the infrared, no, not the visible. Then come the visible, and then the infrared. The infrared will have the largest wavelength in these three. This is the code word for the Ronald McDonald is very ugly except Gary. Radio, micro, infra, visible, ultraviolet, X-rays, and gamma rays. So our answer is gamma rays, visible light, and infrared. So gamma rays, visible light, infrared. So our answer is right. Then satellites are used. Satellites are used in the transmission of some television signals. Figure 10, 4.1 shows a satellite above the television station where a television signal is generated. State which component of the electromagnetic spectrum is used to transmit the television signal to the satellite. We use microwaves for the satellite communication. So we use microwaves. So our answer will be microwaves. So we use microwaves. Okay, the next part. Explain how the satellite is used. And then they say suggest one advantage of using a satellite to transmit television signals. Okay, so basically the satellite will receive the signal from the television station, which is on the ground, and the satellite will boost the signal coming from the television signal from the television station, and then it will retransmit them back to the earth. And on the ground, you know, we have dishes, and those dishes catch that signal, and with the help of the decoder, we can watch the programs. So the satellite receives microwaves and boosts them and retransmit them. So that is our answer. Okay, so let's have a look at the microwaves. Satellite receives and sends, transmit, emit, boost, amplifies the signal. So what is the advantage of using the satellite? You must have observed that we use dish and decoder to receive the television signal, the television programs from the satellite. And one big advantage is that the coverage area of the satellite television is very large. Another very important thing is that you do not require a complicated infrastructure on the ground. You only need a dish and a decoder. The coverage area on the ground is very large, and the minimum infrastructure is required on the earth. That's the advantage. And you must have heard that the reception is very good of that television programs. He says satellite cover a large area over the horizon, only one transmitter station needed, etc., or unaffected by tall buildings or hills and have no obstructions because the dish is directly towards the satellite and directly gets the signals from the space. Okay, so we are going to the next question. The next question is question number 5, and it says, a student rubs a polythene rod with a dry cloth. The polythene rod becomes negatively charged and the cloth becomes positively charged. Describe in terms of the movement of the electrons when what happens during the charging process. So when you rub the polythene rod and the cloth with each other, the electrons has transferred from the cloth to the polythene rod. So that's why the polythene rod has become negatively charged. So let me show you my answer. Here we go. Electrons transfer from cloth to polythene rod during rubbing. Okay, so there is an electric field around the charged rod. So explain what is meant by an electric field. You see, the electric field means that every charge has a space around it. In that space, in that region, if another charge will come, it will experience electrostatic force of attraction or electrostatic force of repulsion due to that charge. So that space around it in which another charge will experience electrostatic force of attraction or repulsion, that space around it is known as the electric field. That region in the space around that charged particle is known as its electric field. So here we go. Space around a charge in which another charge will experience electrostatic force. You can say electrostatic force of attraction or repulsion. A region of space where force is exerted on a charge. So our answer is right. The charged rod is placed near a stream of water from a tap as shown in the figure 5.1. The stream of water bends because the rod is charged. Explain how the charge on the rod cause positive and negative particles in a water to move. You know, in the water molecule, although it has a covalent bond between the oxygen and the hydrogen, it has positive pole and a negative pole in it. So when the water will be passing near this negatively charged rod, the poles which are positively charged, they will be towards this rod, and the water molecule, the negative poles will be away from it. And you know, the positive poles in the molecule of the water, they will be attracted to this rod, and the negative poles on the molecules of the water, they will be repelled by this. And because the distance between the positive and the negative is less as compared to the distance between the negative and the negative, so the force of attraction will be larger than the force of repulsion. So I will just try to show you the answer of this particular question. Negative rod attracts the positive pole in the H2O molecule and repel the negative uh, pole of the H2O. But the water molecule has a covalent bond; it does not have poles. But due to the shared pair most of the time spends time with the oxygen, that's why the oxygen will be negative and the hydrogen will be positive. Okay. On the figure 5.1, draw the charge present on the stream of the water. Okay, so let me show you. So you can see the waters, that portion which is positively charged, that will be near the negative rod. The waters, that portion which is negatively charged, that will be away from the negatively charged rod. So net positive charge on the water near the rod. Okay, so our answer right. I think we have missed the C first part. So I have shown you its answer. I hope I have shown you. Yeah, we have discussed it. We're going to the question number 6. Figure 6.1 shows the current voltage graph of a filament lamp. So here on the y-axis, the current is represented. On the x-axis, the voltage is represented. The slope of this graph will be I by V. So that will be slope is equals to 1 by R. So if the slope will increase, the resistance will decrease. If the slope will decrease, the resistance will increase. If the slope will become constant, the resistance will become constant. State the range of voltages where the resistance increases. So where the slope is decreasing, that is when the resistance is increasing. So from 2 to 12, the slope is gradually decreasing, which means the resistance is increasing. Okay. 2 volt to 12 volt, the resistance increases. State why the resistance of the lamp increases as the voltage increases. You know, as the voltage increases, the temperature of the filament lamp rises, and due to this, the resistance increases. When voltage increases, the temperature of the filament lamp increases, and that is the cause of the increase in the resistance. It says temperature increases, gets hotter. Okay. Rate of the filament lamp is connected in the circuit shown in the figure 6.2. So we have a battery of 6 volt. This resistance of 20 ohm and this lamp are parallel to each other, and they are connected parallel to the battery. So the main point which you should remember all the time, because they are parallel to each other and both of them have been connected parallel to each other and connected to the battery. So the voltage drop on both these will be same. Voltage drop here will be 6 volt. Voltage drop here will be also 6 volt. There are currents in the lamp. There are currents in the lamp, the 220 ohm resistor and the ammeter state what is meant by an electric current. The electric current is basically the flow, the rate of flow of charges. So let me show you my definition. Rate of flow of charge is called current. Our answer is right. It says use the figure 6.1 to determine the current in the filament lamp. The voltage here will be 6 volts and the voltage here will be also 6 volt. So we will look at that graph, and for 6 volt we will check how much is the current. From 6 volt, how much is the current? That is 0.35 ampere. So from that figure I know it will be 0.35 ampere. So from the graph, when the voltage will be 6 volt in the filament, the current will be 0.35 ampere. This is answer is coming from the graph. Okay, now it says state why the resistance of the lamp increases as the voltage increases. This is done. Then the question is, what is the current in the filament? We are done with that. Then the question is, determine the current in the ammeter. So I know the current flowing through this filament 0.35 ampere. I can calculate the current flowing through this branch, then I will add up all the currents. So let me show you. So the voltage drop here is 6 volt, the resistance here is 20 ohm. So I can find out current 1, which is flowing through this branch. And I know the current flowing from here, from the graph paper, that's 0.35 ampere. So the I2 will be 0.35 ampere. We have already calculated it. The I1 will be V by R, 6 by 20, 3 by 10, 0.3 ampere. So the total current coming from the battery will be I1 plus I2, 0.3 plus 0.35, 0.65 ampere. So the current coming from the battery is 0.65 ampere. So you can see our answer is right. 0.65 ampere is the right answer. Okay, so we are going to the next question, and the next question coming up on your screen is question number 7. Figure 7.1 shows a view from the above. The two wires X and Y, these wires carry equal current vertically downward through a piece of card. One complete magnetic field line is drawn around each wire. In this question, ignore the effect of the Earth's magnetic field. On the figure 7.1, draw the complete magnetic field line due to the current in the wire X that passes through the point A. Mark the direction of the field line. Okay, so we will use the right hand grip rule for the straight conductor. And let me show you, I can show you how you can do that. For that purpose, I will switch on my camera. Okay, so this is question number 7. So let me show you. I hope you can see that. Okay, hopefully you can see this. So let me show you. So we will use the right hand grip rule, and the right hand grip rule. Let me bring it here. So take your right hand. This is my right hand, and curl your fingers of the right hand. Because this cross means that the current is going into the page. The current is going into the page. So I will take my right hand. This is my right hand. So I will. Okay. So my thumb is showing the direction of the current. Okay. So the curls of my right hand, the fingers, the curl of the fingers of my right hand shows the direction of the magnetic field around it. So if you look at it from the top, they're clockwise. When the current is going into the page, the direction of the magnetic field will be clockwise. So hope you understand. So stop back. Okay. So here it should be clockwise. So I'll put arrows. Let me show you. I've done this. So you can see I have made another circle around here, and I have drawn it separately. But you can write, you can put arrows here. I have also drawn this. That was for the next question, because here the current is going into the page. So around the wire Y, the direction of the magnetic field will be also clockwise. Here it is also clockwise. But when you look at here in the middle of this wire X and wire Y, you see in the middle, the direction of the magnetic field here, it's downward, and here it is upward. So they are in opposite direction. The current in both the wires is same. So they are at equal distance. This B is the midpoint between them. So here the direction of the magnetic field lines because of the wire X, the current in the wire X and the current in the Y wire is opposite and equal in magnitude. So here there will be no magnetic field. So, and that is because, the reason is that the magnetic fields interacted with each other, and so they have kind of cancelled out each other. Point B is midway between the two wires. Explain why the magnetic field at the B is zero. So our answer is at the B, magnetic field due to current of the X and the Y is equal and opposite, so they cancel each other. Okay. So the magnetic field produced by the B, by the wire X and by the wire Y at the point B, they are in the opposite direction and equal in magnitude, so they cancel out each other's effect. This is our answer. Okay, so let's have a look. Opposite, yeah, that is what we have written the answer. Then their question is, there is a force on the wire Y due to the current in the wire X. State the direction of the force on the wire Y. Explain why there is a force on the wire Y. Okay. We have studied that when you will have two parallel conductors and the direction of the current is same in them, they will attract each other. So because the wire Y will be a current carrying conductor placed in the magnetic field, so it will it will feel a force. So the direction of the force on the Y will be towards the X because the X wire and the Y wire, they have the same direction of the current. They are parallel to each other. So they will attract each other. That's a fact. Explain why there is a force on the wire Y, because Y is a current carrying conductor perpendicular to the magnetic field of the wire X. That's why it's experiencing motor effect. It's experiencing a force. So let me show you the marking scheme. So our answers are right. So now we are going to the question number 8. And in the question number 8, we have two options because it has a question, it has a part which is from electronics part. And the electronics part is optional whenever it comes in the theory paper. It is always in option. Okay, so if you want to attempt this part of the question number 8, it's good. If you want to attempt the other part of the question number 8, even then is good. This is either. Figure 10.1 shows a simple AC generator. The coil is turning and an EMF is induced in the coil. The generator contains a permanent magnet. State the name of the metal used in the permanent magnet. The permanent magnet, for making the permanent magnet, we use steel. So remember this name, a very famous question. Okay, so here we have the marking scheme. Steel, magnetar, alnico, and magnetite. You can use these materials. But the most easy and famous material is steel. Okay, so next question is, at the instant shown in the figure 8.1, the induced EMF is a maximum. Explain why the induced EMF is a maximum. So in this coil, the induced EMF will be maximum because this coil right now is, it is in the horizontal position. So when it will rotate, it will cut it is perpendicular to it will move perpendicular to the direction of the magnetic line. So the number of magnetic lines cut by this coil per unit time will be maximum. So here the maximum EMF is induced when the coil is horizontal. A very famous question, a very, very famous question. Sides of the coil move perpendicular to the direction of the magnetic field lines. So maximum number of lines are cut by the coil in unit time. The next question is, state the position of the coil where there is no induced EMF. When the coil becomes, will go into the vertical position. For a moment, the sides of the coil move perpendicular, not perpendicular, parallel to the direction of the wave, so they do not cut the magnetic waves, magnetic lines of force. So no EMF is induced. So when the coil is vertical, no EMF is induced. It says mention of cutting the lines of magnetic field, change in the magnetic flux, greatest rate of change of, or the fastest cutting, or other explanation involving the time. Vertical, upright, or turned through 90-degree, or normal to the magnetic field. Yes, our answer is right. Okay, so next part. So figure 10.2, this is the, or you can do the upper portion, or you can do in question number 8, you can do this portion. This portion is coming from the electronics. Okay, it says the figure 8.2 shows an astable circuit pulse generator that contains two capacitors C1 and C2, two resistors R1 and R2, and two components labeled Y. He says state the name of the component Y. The component Y, this one. This is actually inverter. It is not gate basically. Whatever will be the input, it will invert it. So whatever will be the input here, or whatever will be the input here the output will be opposite to that. So this is not gate. And here you have the truth table. If the input is 0, the output will be 1. If the input is 1, the output will be 0, because it is, we call it inverter, because it invert the input when it gives the output. Okay. The name of the component is not gate, and if the input is 0, the output will be 1. If the input is 1, the output will be 0. Let me show you the answer. First of all, not gate, inverter. Now the question is, the A-stable circuit produces a series of pulses at the output Q. At one instant, the capacitor C1 is uncharged, output P is 1, and the output Q is 0. Describe how the voltage across the resistor R1 changes until the Q1 becomes 1. So try to understand. Q1 becomes 1 when this will become 1. Here the output will be 0. When here the output will be 0, the input here will be 1. Okay. So the question is, so the if this is 1, the output is 1. Sorry, when the output is 1, the input here will be 0. So this is 0 volt. This will be also 0. So the voltage drop here will be decrease when it will become 1. I don't know if you have understood or no. I will try to explain you again. Voltage across the R1 becomes 0. Input to Y is 0 when the output Q is 1. Let me show you from there again. We know that this will happen. Okay. Try to understand. If this output is 1, it means the input here is 0. When this is at 0 volt, this is also 0 volt. The voltage drop here will be also 0. That is what we have used here. Describe one change to the circuit that increases the frequency of the A-stable circuit, so the pulses are produced more quickly. Very simple answer, just reduce this resistance. When you will reduce this resistance, the charging and charging will happen more quickly. So the pulse here will be more frequent. Okay, so reduce the decrease the resistance of the R. So, my dear students, we are done with the question number 8, and let's have a look at the, and then the question section B will start. Okay, so after this we have the section B. Okay, so my dear students, we have completed the section A of this paper. So today we have attempted May June 2013 Physics 505422 paper, and in this video, in this session, we have done the section A of this paper. The section B of this paper I will do in another video, in another session. Soon I will upload that also. So, and you will find that video in the same playlist where you have found this video. So thank you very much. If you have any problem in checking out the playlist, in the description of this video, you will find all the playlists related with the physics. So once again, thank you very much. It's a blessing for me to be able to teach you, guide you online in the YouTube. And please, if you find this video interesting and informative and is useful to you, please share the link of this video onto your Facebook account and onto your Instagram account and onto your Twitter accounts, because that will help me promote this channel. And also don't forget to subscribe this channel and bring more people to this channel so they can also study physics and practice the past papers for the upcoming Cambridge exam. So thank you very much. Have a good day. God